and we'll start talking about stuff for today. But does anybody have any questions on what we were talking about yesterday? So yesterday was kind of a lot of big ideas that are real important in calculus. You do want to understand those ideas, but they're not concepts at this point where we need to be worried about every single detail. We just want to know the basic ideas of what we were talking about yesterday. And especially when we were talking about the Riemann sum stuff yesterday, that stuff is important, but we don't use that directly a lot in here. We talk about some of the same ideas, but we won't talk about them as Riemann sum. So if we forget some of that stuff, it'd be better obviously if we knew all that. But if we do forget some of that, that's not as huge of a deal. The bigger things yesterday would have been the units. So like understanding that the units of the derivative, how are those related to x and y? Like, is the derivative like x plus y, x minus y, x times y, x divided by y? What are the units of the derivative? Somebody want to tell me?
Y divided by x.
Y divided by x, good. And so like whenever you're dealing with an application, you're gonna know what the units of x are and the units of y are. And we know that the units of the derivative are the units of y over the units of x. And that's important to understand. That's also one of the reasons why you have this symbol. So dy dx is like basically change in y over change in x. And that's a symbol I think that's typically de-emphasized in Calc 1, but becomes a little more important in Calc 2 and becomes a lot more important at the end of Calc 2 and into Calc 3 using this notation rather than f prime of x. This is a more specific notation because it tells you that it's the change in y with respect to the change in x. Does that make sense to everybody? Okay, and so the units of the derivative are the units of y divided by the units of x. The units of the definite integral, the integral from a to b of f of x dx, what is that? Is that x plus y minus y times y divided by y? What, something else? So the units of the integral are
X times y.
X times y. And that basically comes from the fact that it's base times height. So like when you're doing the Riemann sum, the base is delta x and the height is y, which is f of x. And that's actually where this notation comes from. F of x represents the height. Dx is like delta x, it represents the base, and the integral is an s because it's the sum. It's literally saying sum of height times base. So you're adding up the area of a bunch of rectangles. Just in theory, it's an infinite number of rectangles, and the limit of this, the dx or delta x, is approaching 0. That's the idea of a Riemann sum. But the reason the notation is chosen the way it is because it's adding height times base, which is kind of what we were talking about yesterday and what you hopefully got into a lot more detail on in Calc 1. But right now, this is important in here because it tells you how to interpret these things. So like yesterday, if we remember, x was hours because you were driving a car, and y, or f of x, was miles per hour. And because it was telling you that the y was, or I told you that the y was the velocity. So what that means is then the derivative was what? So if I do y divided by x here, what were the units on the derivative? Miles
per hour squared.
Per hour squared, yeah, because you do miles per hour divided by hours, that's miles per hour squared. That meant that it was then acceleration. And then also graphically, we said the derivative is the slope. And then the units on the integral were x times y. So if we did hours times miles per hour, what did we end up with when that happens?
Miles.
Miles, which means the integral represented something in miles, which more specifically was the displacement. And if displacement's just that if you're not driving in the same direction, then it might matter. So like if you went north 100 and south 20, you actually drove 120 miles, but the displacement would be 80. Does that make sense to everybody? If you go like north 100 and then south 20, displacement's 80. That's what the integral actually measures. Clear? Everybody good? Okay, and it's not always that it's miles. It's that given these, then that's what these represent. Okay, so then what I want to talk about first is I want to talk about something similar to driving. But what I want to talk about is if you launch a projectile straight up. Okay, so you launch a projectile or a rocket or a ball or whatever we want to say. Okay, and so I want to talk about how to answer two questions related to this scenario. So if you launch a projectile up, it goes up for a little while, stops, and then comes back down and hits the ground. Does that make sense? So you just like shoot it straight up, comes back down. And so we're going to model the height or the velocity of the projectile at a certain time. And so I want to talk about how to answer two questions. The first thing I want to know is, what is the velocity at 3 seconds, meaning 3 seconds after you launch it. And the second question I want to talk about how to answer is, how far does it go? And more specifically, displacement. So I want to actually know the displacement, meaning the net change in height from 2 seconds to 6 seconds. And now I'm purposely not giving you any functions, but we're going to talk about this in two different situations. So in the situation on the left, I'm going to say that you have a function f of x that represents the velocity in feet per second. And on that part of the screen, so on the left part of the screen, we're going to talk about if you were given a velocity function like we were given yesterday, how would you answer each of these two questions? And then on the right-hand half of the screen, we're going to say instead you're given a different function f of x, which we'll just call big F, a different function, that represents the height of the projectile in feet. Okay? And so on this first middle column, I guess, the middle column on the screen, we're going to talk about if I gave you this function in red, and I'm not giving it to you because I don't want to get an actual answer. I just want to know how we would get it. Okay, so if I gave you the function in red, how would we use that function to answer each of these questions? And then on the right, if I gave you the function in blue and we did not have the one in red, how would we use that one to answer the function or those two questions? Does everybody get what I want to do? Okay, so let's go through that together. So let's, in red on the one on the left, if I said, okay, what is the velocity of the projectile 3 seconds after you launch it? What would you do in this middle column? Would you take the derivative? Would you graph it? Would you plug it in? Would you set it equal? Would you give up because it's a word problem? What would you do?
Plug in 3 for
You
x.
would just plug in 3. Does that make sense to everybody? So on the left, we would just plug in 3. We would not take the derivative. We would not do an integral. We would not give up, hopefully. We would just plug it in and we'd be done. And we know that for a couple of reasons. One is this is telling you velocity and it wants velocity. Second is the units on velocity should be feet per second, which is what this is. Does that make sense? Okay, now over here on the right, what would you do if you did not have the function in red and you had the blue function? How would you do that? Would you plug it in? Would you do a derivative?
Derivative.
Yeah, you would do the derivative. And so you would take the derivative of this and plug in 3. And the reason you would do that, one reason, is because we learn in Calc 1 that the derivative of height is velocity, which is true, but is something we kind of just memorize. Why would you do it based on what we're talking about earlier? Why would we know, other than just having memorized that the derivative of height is velocity, why would you do this based on this discussion?
Because we need to add the units x, which is the seconds. So to get the velocity in feet per seconds, we need the
Yeah.
seconds.
Exactly right. We want to get the units to be feet per second. Does that make sense to everybody? And in this case, the units are feet. So if I do the derivative, the units are going to be y divided by x. I guess I never came out and said that x is in seconds, but that's probably assumed here. I should have said it. But the units here then would be feet divided by seconds, which would be feet per second. Does everybody follow that? Everybody clear? And it is true that the derivative of height is velocity, but the reason why that's true is because the units, the derivative are y over x. Is that everybody clear? Okay, and so one big thing about Calc 1 is that these two things are equal to each other. That the derivative of height is the same as this. So if I took this derivative, I would actually get this function over here, and in either case, we plug in 3 to this. Everybody clear? All right, so a lot of Calc 1 is, okay, how do you calculate this derivative? Rather than using a limit for that, how would we do this using like differentiation rules? Why are those differentiation rules true? How do we use it beyond figuring out how fast a projectile is going? We can use it for lots of things like finding the maximum or minimum, dealing with related rates, which we all block out, but like there's lots of stuff we can use the derivative for, and that's kind of the main point of Calc 1. Okay, and now on problem 2, if we're given the velocity function and we don't have anything else, how would we figure out the displacement from 2 seconds to 6 seconds? So before somebody just gives an answer on that, I don't know the answer, but if the answer was like 100, what would the 100 be measured in for the answer to this? Would it be 100 seconds, 100 feet, 100 feet per second, or something else? Feet. It'd be 100 feet. And I'm making up 100. It's probably not 100, but it's 100 feet. Does everybody get that? Because it's saying how far does it go? So in this scenario, that would be feet. Okay, so if this function gives you feet per second, how can we use that to get feet? Let's get rid of this over here because that's not true anymore. But how can we use that to get feet given what we're talking about up here? Derivative, integral, or is it too hard?
Integral.
Integral. Yeah, so we would do the integral from where to where, do you guys think?
From 2 to 6.
From 2 to 6. Good. So we do the integral from 2 to 6 of f of x dx. And based on yesterday's discussion and what you do at the end of Calc 1, the way you do that is you do a Riemann sum. You divide it into rectangles, you add them up using sigma notation, and you calculate this horrendous limit. Now, most of us learned there's a better way around it, but based on what we talked about yesterday, there's not a better way around it. And so this is the way you would do it, and that would be a Riemann sum. Does that make sense? Everybody clear? Okay. On the right-hand side, what would you do? If you want to get the displacement and figure out how far it goes, would you do a derivative or integral or something else?
Either, just plug in.
You just plug it in. What exactly would you plug in? You're exactly right. What would you plug in?
Big F of 6 minus big F of 2.
Perfect. F of 6 minus F of 2. And so F of 6 gives you the height at 6 seconds. F of 2 gives you the height at 2 seconds. So this is the change in height, which is exactly what displacement means. Does everybody follow why that's the case? Any questions on why you would do it this way? Okay, now let's talk about question 1 again for a second. And if I were to give you guys a test, which is actually going to happen in about 3 or 4 weeks, if I gave you guys a test and both tests had this question on it, and version A gave you the setup that's in red, and version B gave you the setup that was in blue, which version would you rather have for problem 1? Would you rather do this or would you rather do this?
Red.
You'd rather do red because you just have to plug it in. You don't have to do anything. Does that make sense?
Mm-hmm.
Not that derivatives are that hard, but derivatives are a lot harder than just plugging it in. Does everybody get that? Okay, and so like a big thing with Calc 1 is how do you not have to deal with this with the limit? And how do you get this so that you can just plug it in? So down here, if version A is in red and version B is in blue, What would you rather do? Would you rather do a Riemann sum where it's like the limit with sigma notation and all this stuff that we've kind of blocked out, or I hope I've blocked it out, and then, or would you rather do this where you plug in 6, plug in 2, and minus?
Version B.
One.
Yeah, the second one's easier. All you're doing is plugging them in and subtracting them. Here, this is horrendous to have to do. Does that make sense to everybody? You guys clear? Okay, but the idea is that if you're talking about the same projectile, these two things are actually equal to each other. And so the integral from 2 to 6 of this little f of x dx is equal to capital F of 6 minus capital F of 2, because we're measuring the same thing. Does that make sense to everybody? That has to be the case. Now, I purposely didn't give you guys a function for either of these, a formula for either of these, but let's say f of x, this f of x was negative 32x plus 95. Okay, then what we're saying on problem 2 is the way we would do that is we would be calculating that integral. Does that make sense to everybody? Okay, now this equation that I've written on here, which I'm trying to say is a big deal, it is a big deal that this is equal to this. Somebody tell me what's wrong about this. Okay, so this is wrong. But why is this not saying to do this? Or is that what it's saying?
Because it's capital F of x, so it's a different function.
Exactly right. It's capital F of x, which is a different function. Does that make sense? So little f of x is whatever's in here. Capital F of x is this other function. It's not saying that you plug it into this function. It's saying you plug it into this other one. Everybody clear? Okay, but we have an idea about what this other function is. If the function on the left is velocity, the function on the right is height, meaning that the function on the left is the derivative of the function on the right. That means the function on the right is an antiderivative of the function on the left. Does that make sense? Okay, so I know most of us have learned this before, but what's right is I can pick an antiderivative. An antiderivative would be like negative 16x squared plus 95x plus 17 evaluated from 2 to 6. So I have two questions about that. One is, okay, good. I want you to have a question, but let me ask mine first. All right. So one question I have about it is, why is this right? So I want a function whose derivative ends up being negative 32x plus 95. Does that make sense to everybody? Okay, so the function I put here, the derivative of it needs to be this. Why am I right then? What's the derivative of negative 16x squared? You know
Negative
that.
32x.
Negative 32x. And what's the derivative of 95x?
95.
95. And what's the derivative of 17?
0.
0, which is why I can have the 17. And then the guy that said he had a question too, my guess is why 17? Is that your question?
Yes, because in a definite integral, you don't have a c.
Well, you do, but usually you pick c as 0. So let me answer that question in a second. But is everybody clear that it's okay to have the 17 based on the fact that we just need something whose derivative ends up being this? We good? Okay, and I will address the question why I picked 17 in a minute, but let's finish working this out. So if we're not familiar with this notation, or if we forget what this notation is, what this means is now we're going to do this f of 6 minus f of 2. So this function is the big f of x. So I'm going to plug in 6. For all of the x's. And then I'm going to plug in 2 and I'm going to subtract. And it's because I'm doing this. Does everybody see that? The f of 6 minus f of 2. So I'm going to do negative 16. Whoops. I'm going to do negative 16 times 2 squared plus 95 times 2 plus 17. And now I'm going to simplify that, and I'm going to cheat and do this on a calculator real quick, just so we have an answer. But I'm going to assume you guys can do like things like times and minus. And I am getting 478.67, which that number doesn't matter. We're just, it's 0.6 repeating. But anyway, I'm getting about that. But the point is how we compute this. Does everybody get what happened except for maybe the 17 part? Everybody good? Okay, so two things about the 17. One is I could have picked any constant there. Everybody agree? So if I had put 18 here, if I had done 18 here instead, 18 here instead, and 18 here instead, I would have gotten the same thing. And how come?
They cancel each other out.
Yeah, so like whatever's here cancels with whatever's here. And if it was 18, they would have canceled too, and it wouldn't have affected the answer. Does everybody see that? Okay, so they're going to cancel out. The reason it doesn't matter is because the derivative of it is 0. And so the derivative of this is this. Now, in a practical situation, if this is talking about height, then that c really should be whatever the initial height is. Does that make sense? So like the height at time 0. So I never specified what the height at time 0 was. But like if you go back and watch what we were doing yesterday, I said we started like 40 miles north of Morgantown or something like that, I forget. But if I said you shot this up from a height of 17 feet, then this should be 17. If I said you shot it up from a height of 4 feet, this should be 4. If you shot it up from flat on the ground, this should be 0. Does that make sense to everybody? Okay, does that answer the person's question who actually was asking that to begin with? I think a lot of us probably have that question.
Yeah.
Does that help? Okay, cool. Now that corresponds to the plus C thing that we've all seen before. But what this idea is, the fact that this is equal to this, that is the half, it's the more important half, but it's half of the fundamental theorem of calculus. And what it says is that if you're doing this, if you're doing the integral from a to b of f of x dx, that's equal to capital F of b minus capital F of a if capital F is an antiderivative of little f. Now I'm skipping a couple things. This is also if f is continuous on the closed interval AB. Okay, then that's true, and that's half. It's the one that we use more. It's half of the fundamental theorem of calculus. So a huge, huge deal. Okay, it says we're allowed to do this rather than Riemann sums, and it says somehow slope is the opposite of area, which is not an obvious thing when you think about what slope is and what area is. Okay, any questions on this? I know we've seen this before, maybe not quite in this way, but it's real, real important that we understand this. Is everybody good so far? Any questions at all? If you do, just unmute yourself. I'm actually checking the chat right now. No, I'm not either. I don't see the chat at all. So, okay, if there's something in the chat, I'm not seeing it. I don't know why. But all right, we're good? Okay, so then what's going to become important is how do we get from this to that? And you've done some of that in Calc 1. Okay, so how do you find an antiderivative? And we're going to do a lot of that in Calc 2. So today for the rest of the day, and then tomorrow, we're going to review some what's called basic antiderivatives. How do you do this for basic functions that don't involve any advanced techniques, but might be harder than what you did in Calc 1? All right, and then next week, we're going to start to learn techniques to do harder ones. Sometimes antiderivatives are very easy like this. Sometimes they're very difficult, like we will see. And sometimes they're actually impossible. And so derivatives, no matter how complicated, you can do them. If you apply the chain rule enough and you do the product rule enough or whatever you need to do, you can always do them. Antiderivatives, not always possible. So you can make ones that look easy that end up being that you cannot do them, or at least you can't do them using what's called elementary functions. And we'll talk a little more about that later. But let's now talk about what exactly we mean. So if I'm doing this problem, then we now have two symbols that we talked a little bit about yesterday. And there's a difference between what's on the left and what's on the right. But because of the fundamental theorem of calculus, these symbols are basically the same. The integral sign is the same. Does everybody see that? Like this elongated S, if my writing were neater, those would look exactly the same, right? What's the difference as far as the symbol from the one on the left and the one on the right? What's the difference between those?
One on the left is definite.
Yeah, the one on the left is definite, meaning it has these bounds from 2 to 5. So here we're looking for the area under that graph from 2 to 5, which means the answer is going to be a number. Does that make sense? Okay, so this is a definite integral. We're looking for area, which means the answer is a number. On the right, this is an indefinite integral. Which means we're looking for find all antiderivatives of x squared with respect to x. Which means the answer are a bunch of functions. Okay, so let's look at this. So the one on the right, the antiderivative, one antiderivative is 1/3 x to the third. And I think we've learned that before. But why, if I didn't put the 1/3 there, and we hadn't ever done this before at all, which is fair, if I've never done this before, why would x to the third be a good place to start if I'm looking for an antiderivative? What that means is I want the derivative of this to be x squared. What is the derivative of x to the third?
3x squared.
3x squared. So that's at least close to x squared, right? And then if I put 1/3 in front of it, now if I bring the 3 down, what happens? You multiply them and you get 1x squared. Does that make sense to everybody? We good? Now this says find all antiderivatives. So why wouldn't I put this? Like, would that be a correct answer?
Yep.
It would be. The derivative of 1/3 x to the third is x squared, and the derivative of 5 is 0. Does that make sense? Is this right? Yes. Is this right?
Yep.
Yes. Is this right?
No.
No, because now that derivative is no longer just x squared. Does that everybody see that? Okay, so what can I have? Plus any what?
C.
Plus, yeah, we put c, meaning plus any constant. C could be 0, which means it's just 1/3 x to the third. C could be 5. C could be -17. It can be any constant. Does that make sense? Everybody clear? So that's why we put that. Up here, when you're using the fundamental theorem of calculus, you can use any c you want, and it does not affect the answer of a definite integral because it cancels out anyway. Does that make sense? Normally, you don't put this. And so somebody said that you don't have a plus c there, and that's not really true. It's just normally, though, c is 0 because they're not weird like me and put random numbers there instead. Does that make sense? Okay. So that now is all of the answers because it covers plus any constant you want. Now, over here, the answer is completely different. So if I'm doing the integral from 2 to 5 of x squared dx, based on the fundamental theorem of calculus, you pick an antiderivative. So normally you pick the one where c is 0. So you pick 1/3 x to the third, and you put 2 and 5 at the end of the brackets. And now what that means is you do f of 5 minus f of 2, meaning I plug in 5, plug in 2, and subtract like we did above. And so we get 125 over 3 minus 8 over 3, which is then 117 over 3. And then, man, that's weird, but it reduces. So then you get 39, I think, if I'm good at math in my head. But does everybody follow that? Any questions? Okay, so now these two problems, completely different from each other. Does everybody get that? Okay, the answer to the one on the left is 39. If you tell me the answer is 1/3 x to the third, wrong, right? Answer to this is find the area. The area is not 1/3 x to the third, the area is 39. Over here, the answer is this set of functions, 1/3 x to the third plus any constant. And so you have to be careful about what it's asking for, whether it's an indefinite integral or a definite integral. But what we're going to focus on in class is indefinite integrals, because if you do this, if you can do this part, then the rest of this, there is some work to do, but it's just plugging numbers in and subtracting. So I'm going to assume most of the time that you can do this part without me. Does that make sense? Okay, and now I'm going to assume that, and then I'm going to be wrong when it's trig and inverse trig for most people in the class. Does that make sense? So like if it's sine of 5 pi over 4, or if it's inverse tangent of 1, or inverse cosine of -1/2. Those are things that you are expected to know from before without a calculator. And I know that that's not the case for a lot of people, and that's okay, but we need to have an outside session for that. Does that make sense? So like whatever you see in the answers, you should be thinking, okay, would I be able to plug numbers in here and get an answer without a calculator? And if not, you need to say, hey, Doug, let's do a session maybe next week outside of class, and we'll review like how to do trig without a calculator, or how to do fractional exponents without a calculator. Does that make sense to everybody? Everybody clear? Okay, any questions so far? Okay, so what we're gonna now do is a ton of these, and we're gonna build them from like real basic, and we're gonna get them harder, and then we're gonna get even harder next week and tomorrow. But at this stage, so yesterday, the stuff was kind of an overview, and up till now, this was kind of an overview. Starting now, we need to understand every single detail of every single problem. And if you don't, you need to unmute yourself and let me know. Don't feel dumb. Not everyone understands everything. So please, though, let me know, because we need to understand every little detail on all these examples, because it's just going to build and get a lot harder. And if we don't understand these, then it's going to be impossible when we get to the harder stuff. Does that make sense? So please ask. I will not be mad. All right. Any
Someone
questions?
asked if we're having class tomorrow.
I think we are going to have a class tomorrow. Of course, it's optional. So the ones I want to go over tomorrow are ones that involve trig identities. And unless we get to them before 2:15, then we're going to go ahead and do that tomorrow. If you don't want to come on Friday, I understand, and you can watch it later. But the ones with trig identities, I think will mess people up a lot, and I want to practice some. If we have time today, I keep forgetting we have until 2:15. I'm thinking too. If we have time between now and 2:15, I'll go ahead and get it done today, and then we won't have class tomorrow. But let's see. Okay? Let's see how this goes. All right. So number one. So either way, though, all of that stuff is going to be done this week, whether we cover it today or tomorrow. And we have to cover new stuff next week, so we got to get it before the homework. But let me put a few up. These are going to be real easy. And like I said, we're going to build them pretty fast. All right, so real fast. If we had not done this before, if we do not remember this, you were looking for a function whose derivative ends up being x to the fourth. You should start with x to the fifth, because the derivative of x to the fifth is 5x to the fourth. And so it's not what you want, but it at least has the x to the fourth. Does that make sense to everybody? Okay, so you start with x to the fifth. Now you put 1/5 in front of it, because then if I bring the 5 down, 1/5 times 5 is 1, and I get 1x to the fourth. Everybody clear why that is correct? Okay, and then we put plus c, because that is always going to be there for an indefinite integral. The derivative of any constant is 0. Okay, any questions? Like I said, I know we're starting real easy, but we're going to build quickly. So if you have a question, let me know. Okay, and so same deal on the next one. start with x to the 8th because the derivative is 8x to the 7th, put 1/8 in front, and then we put plus c. Does that make sense? Okay, that leads to this rule that the integral of x to the n dx is equal to 1 over what, based on what we're doing there?
N plus 1.
Good, 1 over n plus 1, x to the n plus 1 plus c. Does that make sense to everybody? We clear? Okay. Does that always work? So somebody say no? Okay. It does not, but does it work for like -4? Does it? Okay. So if it does, you get 1 over, what's -4 plus 1?
-3.
Good, -3, 1 over -3, x to the -3 plus c. Please don't ever leave an answer like that, but that's what the rule says. So is this right? How can I check?
Yes.
Yeah, it is. So you bring the -3 down. 1 over -3 times -3 is +1. And then when you do the derivative, -3 minus 1 is -4. So you do get x to the -4 as the derivative. Does that make sense to everybody? That's clear? Okay, so that does work. Now you should simplify that and rewrite it as -1 over 3x to the 3rd plus c. And now that's the actual answer, but you start it using that rule. Does that make sense? Questions? Okay, so it works for -4, and that should have been probably number 3. We don't need 2 number 2s. All right, so number 4, does it work for fractions? So if I have x to the 2/5, so what's 2/5 plus 1? Without a calculator, what's 2/5 plus 1?
7/5.
7/5, good. So then what this rule says is I get 1 over 7/5. Man, that's supposed to be a 7, not a weird circle. 1 over 7/5, x to the 7/5 plus c. And of course, don't leave the answer like that, but that's what the rule says. And so if I bring the 7/5 down, it cancels, and I subtract 1 from the power, and I get this. Does that make sense to everybody? So that does work, but then you should probably write this as 5x to the 7/5 over 7 plus c, because the 1 over 7/5 flips. Okay, any questions on that?
Hey, Doug, I got to go. I got a class at 2.
You were completely fine. Just maybe catch up on the video later, okay?
Yeah, absolutely.
I'll post it tonight. Cool, thanks.
Cool. Thank you.
No problem. All right, everybody good on number 4? That's good. Okay, so this works when it's x to a positive integer. It works when it's x to a negative power. It works when it's x to a fraction. Does it ever not work when it's x to a power? Are there any cases where this does not work? The answer to that is yes. Yeah, Jordan, when x is -1, or well, when n is -1, but yeah, I get what you're saying. So when n is -1, this doesn't work. So let's see why. So if I have the integral of x to the -1 dx, then I get 1 over 0 x to the 0 plus c. What's wrong with that? Please don't copy that down as though it's right. It's not. What's wrong with it, Dominic? Sorry, go ahead.
You can't divide by 0.
Yeah, you can't divide by 0. You're a little choppy on your phone. That's okay. All right, you can't divide by 0. 1 divided by 0, if you didn't know that before, 1 divided by 0, that is completely meaningless. So this is a complete crap answer. Okay, you cannot have 1 over 0. Clear? Okay, so there's no way that's right. That's completely undefined. It's completely meaningless. We don't have an answer for that, or we don't have an answer when we put that. And so then, okay, you cannot use this rule. So this rule, it turns out, does work for any power n except -1. So it works for 2/5, it works for -4, it works for -1,000,000, it works for any number except -1. But if it is -1, why would it be smart to rewrite it that way? So remember, we're thinking, what do you take the derivative of to get this? So
ln
think
of
back
x.
to, yeah, somebody said it, ln of x, natural log of x. So if you take the derivative of natural log x, then you get 1 over x as the answer. Does everybody remember that from Calc 1? Okay, so then this is natural log of the absolute value of x plus c. The absolute value is a technicality that has to do with the domain of log. And we can talk about that in a second if people have questions about it. But aside from the absolute value, does it make sense why it would be natural log? Because the derivative of natural log is 1 over x. Clear? Everybody good? Okay, and so that is right. Real fast, I'm going to give an explanation as to why you need the absolute value. So when you talk about natural log, it's understood that whatever's inside of natural log has to be positive. Not only can it not be 0, but it cannot be negative. When you write 1 over x, it's assumed that x is not 0, but x could be negative. And so this takes care of that. It's a little more technical as to why it's okay to just throw an absolute value in there, but we can think of it as, okay, when x is negative here, now x is still negative, but its absolute value is positive, which means log is not like undefined. But that's why you need the absolute value. We can go into more detail if you're interested outside of class, but that's the idea. Okay, any questions on that? Okay, so then the second rule for antiderivatives is that the integral of 1 over x dx is natural log absolute value of x plus c. Does that make sense to everybody? We good? Okay, now those two rules, super, super important. You don't need to necessarily memorize the rules, although I think you will eventually. But what you need to be careful about is they're very specific as far as how they're written. So here you have x to a number. You do not have 4 to the x. You have x to the 4. Does that make sense? Okay, so it's x to a number, and then this dx is super important. Here you have 1 over just x. You do not have 1 over x squared. Does that make sense? Okay, you don't have 1 over x squared. You have 1 over x dx. If that's the case, then you can do this. So I'm going to put 3 or 4 problems on the screen where I'm trying to use these rules, but I'm going to do at least one of them wrong. And I want you to tell me why some of them are wrong and then how we can fix them. So I'm going to put these problems up. So some, or at least one. Okay, so if I have like, all right, well, if I have like, okay, so the 3 up here, at least one of those is wrong, and I want to know which one or which ones are wrong and why.
The first one.
Okay, first one's wrong. Is everybody clear why? Or was everybody clear that it's wrong?
Yes.
Okay, now everybody look look closely at the screen for a second. All of us right now know that the integral of 1 over x cubed is not log of x cubed. We clear? Also, the integral of 1 over 3x plus 5 is not log of 3x plus 5. Okay, that's bad. Both of those things are bad. And I know that we know that right now, but in the middle of a big test, where you're trying to get all your answers right and you're freaking out about having 20 more to do, it's easy to do this. And it's completely wrong. Does that make sense? So just be real careful. You cannot use that rule unless it's exactly like this. If it's 1 over x to the first and then dx, that's when this works. The letter could be different. It could be 1 over y dy, or 1 over c dc, or whatever, or 1 over u du, which is more common, or 1 over v dv. But that letter must match that letter. This must be x to the first, or v to the first, or u to the first. But that's it. It cannot be used in any other way. Does that make sense? Okay, so it must look exactly like that. So 1 over x cubed, not this. 1 over 3x plus 5, not this. If you're doing that, it's wrong. Clear? And like I said, I know when we back up and think about it, we know that, but it is easy to do this, especially this, on a test when you're just kind of working with a bunch of other stuff, if this is in the middle of a bigger problem. So let's be careful. So let's fix this. Okay, so you cannot do that. So what can you do instead?
Make it x to the negative third dx
Yeah.
and take the integral from there.
Perfect. So let's rewrite it as x to the negative third dx. And now it matches the first rule, right? So x to the negative third matches that one. So we've got 1 over negative 2, x to the negative 2 plus c, which is negative 1 over 2x squared plus c. Does that make sense? Everybody clear? Now that's something worth noting, that most of the time, rather than a fraction, you would rather have a negative exponent. That's usually easier to deal with. Everybody see that? Okay, most of the time the negative exponent is easier to deal with than the fraction, at least within the integral. The exception is when it's x to the negative 1. Then the fraction's easier to deal with because that's when it would become log. Everybody clear? You guys good? Okay, now what about the second and third one? Are those both right?
The second one's wrong.
The second one's wrong.
Yes.
Why is the second one wrong?
Because it's with respect to y.
It's with respect to y. So the problem is, and let me erase that, that when it says with respect to x, that means if I take the derivative of this answer with respect to x, I should get what I started with. Does that make sense? If I take the derivative of this answer with respect to y, what would that be? What's the derivative of that with respect to y, do you think? With respect to y, x is a constant. Does that make sense? Okay, so with respect to y, x is a constant, meaning this is a constant. What is the derivative of a constant?
0.
0. And then what's the derivative of c, which is still a constant?
0.
0. And 0 plus 0 is 0, which is nice and correct, but is not helpful for this problem. Does everybody see that? Okay, so this is wrong. Now we'll put in green what's right again, because that seems to be the color code I'm using on this page. So any idea on what you would put?
X to the fourth y.
Yeah, good. Nice. X to the fourth y, because that's like a constant. And so x to the fourth may as well be like 17. So it'd be like the integral of 17 dy is 17y. Same deal here. Now that's real weird, and you probably won't see that until Calc 3, where you're doing. Go ahead. Okay. You're good. You're good. Okay. But what you will do starting next week is we're going to start to change variables. We're going to be using x and u. And then later we're going to be using x, u, and v, and then sometimes some more. So we're going to start to change variables. None of the rules work right unless the variables match. So if this is x and this is y, it doesn't work the way you want. Does that make sense? Back up here, if this is x and this is x, that's fine. If it's y and it's y, that's fine. That's okay. You can do this. Y to the n plus 1 plus c. But the letters have to be the same. It cannot be y here and x here. It cannot be u here and x here. Does that make sense? Okay, so you have to be real careful. We'll make a big deal about that again next week. If you don't understand why it's this, that's not as big of a deal. But what we'll talk about next week is what we really do need to understand is this dx must match the variable here. Dx must match the variable here. If it's du, then this must be u. If this is dy, this must be y. Does that make sense? Okay. All right, and then is this last one right? Yes, so the last one is actually okay, so we're good. Okay, any questions on those three? You guys good? Okay. All right, so we got two rules. We got the power rule, we've got the 1 over x rule, and I am gonna, real quick, before we do these next problems, I wanna pull up, if you go to your Google shared drive, then in there, under Unit 1 integration techniques, you should see this formula sheet. And I'm going to show it in just a second. And so you should see this. And on this, you've got a bunch of integration formulas that come directly from the derivative rules from Calc 1. And x to the n dx is the one that we've talked about a lot already. X to the -1, I guess I went ahead and rewrote it like that, but normally we'd rewrite it as 1 over x, and then that becomes natural log absolute value of x. The next one we're going to talk about is e to the x dx, and I'm not going to rewrite it because I hope that's obvious. Because this just means what do you take the derivative of to get e to the x, and what do you take the derivative of to get e to the x? Somebody knows, it's right here. E to the x, good. Does that make sense? Everybody clear? Okay, so these three rules are the ones we're worried about right now. We'll get to these other 8 tomorrow, or yeah, it's gonna be tomorrow. But these three rules are the ones we're worried about right now. Let's go back and talk about some problems where we use those. All right, so the third rule is the integral of e to the x dx is e to the x plus c. And that rule is right. Real quick, what does it tell you about these problems? So based on this rule, what's the answer to the first one? Or is it too hard? E to the u plus c. We're allowed to use it because the variable here matches the variable here. This is u and that's u, so it's exactly in that form. Does that make sense? What does that rule, as written, tell you about the second problem? So what does it tell you when there's a 3x up here? Nothing. Does that make sense? This doesn't say what happens if there's a 3 there. Everybody clear? You may know what happens if there's a 3 there, but this rule does not tell you. Clear so far? Okay, so for right now, based on what we have talked about, this is too hard. Okay, so we cannot do it based on this. It's not that hard. We're gonna learn how to do it Monday. It's easy to handle, but it's not, does not match this rule because of that 3. Does that make sense to everybody? Good? Okay. All right, what does, so we've got 3 rules. We've got e to the x, we've got x to the n dx if n is not -1, and then we've got 1 over x dx, and that's if n is -1. So these 2 rules together cover every power function, meaning x to a power. This covers one specific exponential function, meaning a number to the x. Is everybody clear? Okay, so power functions, exponential functions. We've not talked about like 3 to the x. We'll talk about that next week as well. But this covers all power functions and then this exponential function. What do these rules tell you about this? If we're applying the rules directly, do they tell you what to do when it's plus? These 3 that I've got. They do not. They don't say anything about plus. What do you do when you're doing derivatives and they're plus? So if you
Break
have
it up.
Yeah, you break it up. And so when you do derivatives, if it's addition and when else? Addition or what? You can break it up.
Subtraction.
Subtraction. If it's addition or subtraction, you can break it up. So we actually have these two rules. The integral of f of x plus g of x dx, that's equal to the integral of f of x dx plus the integral of g of x dx. And they are on that formula sheet down about halfway on the page, or toward the bottom of the page, I think. So definitely use that formula sheet, but that's there. And what it says is you can split this up. So you can make it the integral of x to the 6th dx plus the integral of x to the 8th dx. Does that make sense? Now, does this integral match one of the three rules? It does. It's exactly x to the n dx. So this is 1 over 7 x to the 7. This second one also matches. It's 1 over 9 x to the 9 plus c. 2 comments about that problem. 3 comments about the problem. 1 is it's easy, right? Okay, addition's easy to handle. Second comment is we only have 1 plus c. And the reason why is because you can have a constant with this one and a constant with this one, but then you can just combine them and put it as one constant at the end. Does that make sense? Okay, so we have one constant usually. And then the third thing is, how many of us could have done this problem correctly without this middle step? I hope all of us. All of us should have been able to skip that middle step. I want you to try not to. And not because I'm going to count off if you're not showing every little detail. That's not the reason. What I want you to get, and it's not because I don't think you can do this problem without writing that middle step. I know you can. The reason I want you to get in the habit of writing that step is because what you do want to get in the habit of is making sure that the integrals you're doing match one of the rules exactly. Because if they don't, if they're a little bit off, you may be doing the problem wrong. And when they get harder, which they will fast next week, when they get harder, if they're just a little bit off, you can do the problem completely wrong because you're applying a rule that doesn't actually apply. Does that make sense to everybody? So we want to be real careful to make sure to try to get it exactly in one of these 3 forms. And after tomorrow, there will be 11 forms. And if it doesn't match the forms exactly, then we should not be doing the integral yet. Does that make sense? Okay, but we can split it. And like I said, we can all do it without writing the step, but try to get in the habit of not doing that because we want to match these rules exactly, especially for harder problems later. Now, what about if I have like 7 x to the 5th? So when you have a constant multiple for derivatives, like if I was doing in Calc 1, if I said, okay, f of x is 4 natural log x, and I said, okay, find the derivative. How does that 4 behave when I do the derivative of that?
You just keep it.
You just keep it. The 4 just sits there. And so you do 4 times 1 over x, which then simplifies. But the reverse of that for antiderivatives is the 7 just sits there. And so the rule we write is that the integral of k times f of x, a constant k times f of x dx, you can pull the constant out. And that's the reverse of when you have a constant multiple for derivatives, it just sits there. So when you have a constant multiple for integrals, it just sits there. So we can pull the 7 out. Now, again, all of us could do this problem without showing this step. But what is the benefit of this step as far as what I was talking about over here? Now, what is the case that wasn't the case here? So what's true about this step that's different from the first step as far as these?
It matches the rule.
Now it matches the rule. So you've got x to the n dx. Does that make sense? So now we've got 7 times 1 over 6 x to the 6th plus c, and that simplifies to 7x to the 6th over 6 plus c, and that's the answer. Any questions? All right, let's review a couple tougher things and then. Okay. So far we've talked about now 5 rules. Okay, 3 forms, e to the x, x to the n, and 1 over x. Those actually let you do antiderivatives. And then the sum rule and the constant multiple rule. And what those let you do is break it into easier integrals. They don't actually do the integral for you. These 2 rules together mean you could also split subtraction. Does that make sense? So like the k could be a -1, meaning you can split subtraction, but you cannot split multiply, divide. So anyway, we've got those rules. None of them have radicals or square roots or fourth roots in them. How could I rewrite this so that it's like something we know how to do?
Into a fraction.
Yeah. So we can rewrite this as x to the 3 over 4 dx. Okay, that's a rule from algebra that if we don't remember, it's the power inside over the index of the radical when you do that. That now matches the form. 3/4 plus 1 is 7/4. So we get 1 over 7/4 x to the 7/4. Let's make that a little bit neater. Which is then 4x to the 7/4 over 7 plus c. These are going to build fast now, but does everybody follow it? Is it good? Okay. Now, the constant multiple rule with the addition and subtraction rule lets you do stuff like this. Okay, so if I have adding and subtracting, I can split those up into several integrals. And when I have constants, I can pull those out. So to make this match the rules that we've got, I'm going to rewrite this problem like this. Does that make sense to everybody? So I'm splitting, adding, and subtracting, and I'm pulling constants out. Again, this is one where maybe most of us could do this without this step, but now every one of them looks exactly like one of the rules, x to the n dx. They all look like that one. And so now the integral of x to the 5 is 1/6 x to the 6th. The integral of x to the 3rd is 1/4 x to the 4th. The integral of x squared is 1/3 x to the 3rd. The integral of x to the 1st is 1/2 x squared plus c. That simplifies to this. Questions? You guys all good with that? Okay.
I have a question about simplification.
Sure.
How, I remember from calc last year that we didn't really have to simplify things that much. How much do we have to do it here? Like, do we have to have it that final answer that you have?
I'm meaner about that, and I apologize, but yeah. So on WebAssign, I think it does not make you simplify. But when you're doing a written test or written quiz, you should simplify as much as possible. Does that make sense?
Yeah.
No, you wouldn't lose like a ton of points, but like, yeah, we should be simplifying. And one of the main reasons for that, a couple of reasons. One is it's just better mathematically to do it. But especially if you guys go on and take Calc 3 and stuff, the people teaching those classes, if they see this as the answer, they're going to think you don't know what you're doing. Does that make sense? And I mean, I know you do, but like if they don't see this, they're going to think you don't know. Okay. Sorry. I'm just trying to be honest. Okay. Any other questions so far? Is it good? Okay. All right. Let's look at this problem. Okay. All right, so if you think you're good on this, if this is easy for you, keep working it. If not, I'd maybe watch me do this first step and then copy it down in a minute, just because it's a little weird. So we're going to split this into 5 separate problems. And when we do it, on the first one, we're going to pull out the constant. And the constant is 3/5. And then because the x to the 4th is in the top, we're going to put x to the positive 4 dx. On the second one, we're going to pull out the constant, which is 6/7. And then because the constant or the x squared's in the bottom, we're going to bring that up and make it x to the -2. Does everybody follow that? Why I'm doing that? Any questions on that? Okay, so then what constant would I pull out of the third one? Would I pull out 3 or 1/3? It'd be negative, but would I pull out 3 or 1/3 or something else?
3.
3, because the 3 is on top. So it's like 3/1. And then inside I get x to the -3 because it was in the bottom. On the next one, I'm going to pull out 1/5. And then put x to the first inside. Does that make sense? Everybody good? Okay, and then on the last one, I'm going to put 4/3 outside, and I'm going to leave it as 1/x dx inside because I don't want x to the -1. Like when I have 1/x cubed, I want a negative power. When I have 1/x to the first, I want to leave it like this and use log. Questions on how to break that up? Those are all good. Okay, so then we've got 3/5 times 1/5 x to the 5th minus 6/7 times 1/(-1) x to the -1 minus 3 times 1/(-2) x to the -2 plus 1/5 times 1/2 x squared minus 4/3 log absolute value of x plus c. And now that simplifies to 3x to the 5th over 25 plus 6/7x plus 3/2x squared plus x squared over 10 minus 4/3 natural log absolute value of x plus c. And man, I did that fast, but does that make sense? Questions on any of it, on how to break it up, how to simplify that? Is this pretty easy for most of us still? Okay. And like I said, try to get in the habit of doing this second step where you make them all look like one of the rules. The one exception to at this stage, there'll be a couple later, but one exception to making them look exactly like one of those rules is if you do have like just 7. All of us should know that, but if you have a constant inside, you don't want to pull that out if it's just a constant, and just think through, okay, what's the antiderivative of 7 with respect to x? Maybe we don't know that.
7x.
7x, yeah. Now, if it was like 7 du, it'd be 7u, but it's just the constant times x. So if you did have like just plus 7, you'd leave the 7 inside on that integral. Does that make sense? I just forgot to actually include that as one of the examples. Okay. So then what we should do, so here's the deal. I did not want to have class Friday, and in all of the classes technically are optional. I think it helps to come live, so I would do that. But what you need to do is we need to do the homework called Basic Antiderivatives 1. I think the deadline's listed as tonight. I'll probably extend that until tomorrow before class, so we'll make it due Friday, and we'll say, man, class is at 12:30, so we'll make it Friday at 12:15 p.m. So that one has a lot of problems like this, but we just probably did 20 on this video. So it's going to be like that, where it's a bunch of this stuff. There may be a few things that you have to figure out how to deal with algebraically, like if it's division or multiplication. If you can't figure them out, let me know, and we'll go over them tomorrow. Tomorrow, it's still review. So if you're good with this stuff, fine. But tomorrow is going to be trig. And it's not just going through the rules, it's using identities in order to match the rules. And so normally I would not try to have class on Friday, but the reason I'm going to this week is because we've got to go into the new material next week, U substitution. Trig integrals are something where the textbook kind of assumes you know this already. We're supposed to kind of assume you know this already. I think most of us are not super comfortable with trig, identities, and integrals. And so if you can come tomorrow, I definitely would. If not, I'll record the video and post it, and you can watch it later if you want to take tomorrow afternoon off. I completely understand. But that homework is basic antiderivatives 2. And then that's going to be due, Monday before class, so 12:15 p.m. And I think WebAssign's probably not saying that yet, but it will say that. Okay? Okay, any questions before we get off here? All right, if you do, stick around. Thanks for coming. I hope it's worth coming to a live lecture. I think it is. Do you guys think it's worth it or no? I mean, you don't have to say it's happy to me or to make me happy. Okay, I think it's worth it. So if you can, keep coming. We'll do it again tomorrow. And the next week we'll be into U substitution, which is technically supposed to be new. I know some of us have done it, but we will get into a harder level than what you did no matter what, if you did in Calc 1 sometime next week. So, all right, stick around if you have questions. If not, I will see you guys tomorrow. Have a good night. Thanks.
Hey, can you hear me?
Yeah, sure. What's up?
Yeah, so I kind of have like a grading based question.
Yeah,
on
no.
The last problem. So I kind of did it a little bit before you, and I got it all right. But when you separated them into different integrals,
Yeah.
on the very last one, I made it x to the -1, and
Fine.
I recognize that as like log still, and I got it
Yeah,
right.
sure. As long as you knew that it was log, completely fine.
Okay. All right.
Yeah. As long as you're not doing something like this mathematically illegitimate, you don't have to do it exactly the way I do. I'm just trying to make it the easiest for later. But as long as you know x to the -1, that's not any harder. Okay?
All right.
So
yeah, that's all.
Okay,
Thank
cool.
you.
No problem. How about you all? Kaylin, Rachel, Trevor, who else is in here? You just the first 3 has them? All right.
So,
Yeah.
I had a question. I wasn't at the class yesterday because I have a class. But,
Okay, that's fine. Were you able to watch?
I watched the videos before this class, and
Okay.
I'm just kind of so the videos like aren't like you don't have to do them. You do them because they help. You see them.
Like these live ones?
Yes.
Yes,
So if there
but-
wasn't that, other than these videos, what other other than like our math homeworks?
So you are,
like
you're
material?
not required to come, Kaylin, but you are required to watch them. So
Okay.
like they are the class. Does
They're
that
just
make
live.
sense?
Okay.
Yes. I just think it's, rather than me recording it last night and having you guys all watch it today, what I'm doing is I'm just recording it while you guys watch. Now,
Okay.
there are pre-recorded videos that I made over the summer, but I think these will be much better for you because they're the pace. So those were made by topic, and these are going to be made by what we're doing. Does that make sense?
Yes,
So
thank
like, yeah, so that's how I'm structuring the class because I really think it's better. I think it's better if you can come, but if you can't come, the next best option is to be watching these every night as soon as I get it posted. Is that
Okay.
fair?
Yes, thank you.
Okay, cool. Yeah, no problem. Are you normally able to come or no?
I have class at 1 Monday, Wednesdays.
Okay.
So
Monday
I can
to
watch
Wednesday?
like the first 30 minutes, but then like I'd be in a class after
Well,
that.
then don't worry about it. And then just watch the things later. And then I'm going to have office hours and hopefully they'll work with your schedule. And if they don't, we'll meet up
Okay.
to go over whatever you need to.
But I
like,
can watch
yeah.
like Tuesday, Thursday ones.
Yeah, and then you can come in on Tuesday, Thursday, and then like probably what'll happen is, unless I'm traveling on Fridays, we're not going to have lecture most times. So if you wanted to meet up on Friday, we could, you know, and I just kind of have that open. And then I'm going to have set office hours. Like, I want to help you with it. It's just, I wish they had put a time on the schedule and said, okay, everyone's in class, because I think that'd be easy for you guys. That wasn't our choice. So I think this is the best option, but I'm not trying to require you guys to come. I just had to pick a time. If I could have picked one and I said, okay, everybody could make it, there was no way to do it. I'm sorry.
No, yeah. Thank you.
But yeah, is it helping? Did it make sense today? Okay, cool.
Like watching the videos helped a lot already.
And the video from yesterday made sense? Yeah, but that's the main thing I want you guys doing. And then I will have tons of material for you. We can meet up. We can do office hours, all that stuff. I do not want you doing this as like a self-study class.
And then I had another question. So for like our big exams we have, is there going to be like live review sessions like this kind of?
There will. Yeah, I hold live review sessions anyway. Now I'll probably open that to all of the Math 156
because I think I might have went to, so I took a semester off.
Okay.
Last semester for the military, but the prior semester I took Calc 2.
So you probably came to my reviews anyway.
I went to one before the final.
Okay.
And I liked, so that's why I took your class.
Well, I appreciate that. Yeah, so I would do them in person. I don't think it's safe to do it in person. So it'll be like this, but it'll be question and answer. I'll probably do 2 before each review, assuming turnout's good, or before each test, you know, like Monday night or Tuesday night or whatever.
Okay.
And it'll be like this, where I'll have to just kind of pick a time and hope that you can come, but I will record them. So like, if you can't come, I'll record them and post them the next day. So yeah. Okay.
All right. Thank you.
Awesome. Yeah, no problem. I'll see you later. Glad you're in the class.
Bye.
See ya. How about you guys? Rachel, Trevor, Bailey, you're in the next class, I think, right? Let's get this off of here so I don't freak everyone out in that class. All right. Everybody good? I'm actually going to cut out of here for like 5 minutes. And if you're in 150, I think it's going to kick you out. And then I'm going to let you back in just a minute. If you guys are in my 156, today, on Tuesday, Thursday, I have a class right after this. So I'm going to end it. But I will email me. And if you need to talk tomorrow, we can talk more before and after class tomorrow. Okay, but I'm going to have to sign off of here. And I think, Bailey, you're just still trying to connect to Wi-Fi or into the audio. I think it's going to kick you out, and then we'll be back in just like 5 minutes for your class. Okay. Sorry if you can't hear me.